All right, let's look at this theorem, which says if f is a linear transformation on plane P, then so is f inverse. Right? So if you have a linear transformation, its inverse is going to be a linear transformation. Right? So as a homework, we already showed that f inverse is a transformation. So we just have to show that it is actually linear. All right, so let's do that. All right, so first we assume, so we know that the given is f is a transformation. All right, so f is a linear transformation. Maybe I'll just say f is linear. All right, so this is given. All right, so let's do proof by contradiction. So I'm going to just say proof by contradiction. All right, so let's assume, so 2. So assumption would be f inverse is not linear. So assume that f inverse is not linear. All right, so this is for indirect proof. I would just say indirect proof. Right? And then, so what can you say? So f inverse is not linear. So there should be, there exists 3 collinear points. Collinear points. I'm going to call it A, B, C in this plane P, such that, right, so the linear points are not going to be linear after you apply f inverse. So we say f inverse of A, f inverse of B, and f inverse of C are non-collinear. Right? So this is from line number 2. Assumption is it's not linear, which means that the some collinear points will be mapped to non-collinear points. Right? So once you got that, then we can say line number 4. All right, so why don't we apply f to those 3 points? If you apply f of, so these are non-collinear points, so you have f inverse of A and f of f inverse of B and f of f inverse of C, right? So these are going to be still non-collinear. Right? Since we established that in lemma, if you have a linear transformation, it will preserve non-collinearity. So this is by lemma. Right? So by definition of inverse, so we know that f of f inverse of A is simply A, and f of f inverse of B is B, and f of f inverse of C is C. So the A, B, C are non-collinear. Right, which is already a contradiction because let's say line number 3 says that we actually have A, B, C at collinear points. So here we have that. Right, so that comes from 4. Right, then therefore we already found a contradiction, so we can make a conclusion. So what we assumed up here is wrong. So we know that therefore F inverse is linear. All right, so I guess this is by rule of elimination. All right, so this will prove that if you have a linear transformation, then its inverse is always also linear transformation. All right, that's it. I hope that this was clear.